Every week, a new AI model drops. The 2026 release cycle keeps rolling in, and most companies are signing contracts based entirely on marketing claims instead of actual performance metrics. Anthropic has always taken a different angle. While OpenAI and Google prioritize raw response speed, the Claude lineup was built to focus heavily on measured reasoning and safety rails. Take a look at this chart mapping out Anthropic's three-tier system. Understanding this layout is the only way to figure out what you actually need. We have context size on the bottom and agentic autonomy on the side. Down here in the corner is Claude Haiku, optimized entirely for speed and efficiency. Right in the middle is Claude Sonnet, built to be the balanced daily driver for most standard tasks. And isolated way up here in the top right is Claude Opus 4.7. This is the flagship heavy lifter, engineered specifically for advanced reasoning and autonomous workflows. Treating these models as interchangeable general-purpose chatbots ignores the engineering differences between them. To use Opus 4.7 effectively, we have to look at the specific tasks it was actually designed to handle. So, what does this release actually deliver? The headline features are a 1 million token context window, paired with heavily upgraded AI agent functionality. But the immediate question for any technical director is whether those massive specs actually solve real workflow bottlenecks, or if they're just expensive vanity metrics. We aren't doing a standard feature review today. Instead, we are going to run a specific scenario match to figure out exactly who needs to upgrade and who is about to waste their money. We don't need to prove if Opus 4.7 is technically the smartest AI available. We need to prove if its premium capabilities generate enough value to cover its steep operational costs. Standard models have memory limits in the thousands, filling up immediately. 1 million tokens effortlessly absorbs an enormous amount of information at once. In the past, those smaller limits forced engineers to chop up their datasets into fragments and rely on complicated workarounds just to get the AI to read a full project. This diagram shows Opus 4.7's input advantage. Drop massive, unfragmented datasets, like entire software repositories, into a single, unified block. The model holds the entire library in active working memory, connecting dots across hundreds of documents without forgetting your original instructions. You can ask it to trace a single software bug across 30 different code files simultaneously, or feed it 5 years of vendor contracts and instruct it to flag every liability inconsistency. This context capacity shifts the model from a simple reader to a large-scale reasoning engine. By holding the full dataset in one place, it removes the need to manually bridge insights between disconnected prompts. The second major capability upgrade focuses on how the model actually works through those large tasks. Anthropic heavily refined the model's autonomous agent functionality. Instead of pausing to ask for human confirmation after every single step, Opus 4.7 can reliably execute long-running, multi-step pipelines with minimal supervision. Look at the scorecard from the SWE-bench software engineering test. Opus 4.7 clearly beats competitors like GLM 4.7 in agentic coding output. The breakdown shows this high score comes from multi-step task reliability, the model's ability to plan a sequence of actions and actually finish them. To achieve this reliability, Anthropic introduced a critical behavioral shift. Opus 4.7 now interprets instructions completely literally. It takes zero creative liberties with your prompt. The trade-off here is steep. If your prompts are lazy, vague, or imprecise, the execution will fail immediately. You have to engineer exact, rigid instructions for every task. That literal interpretation is exactly what you need to guarantee predictable outputs for an autonomous pipeline, but it requires a severe habit reset for users who are used to older AI models guessing what they actually meant. But before you swap your entire workflow over, we need to look at the severe infrastructure friction of running Opus 4.7 in a live production environment. This chart shows the financial reality. API pricing for Opus 4.7 sits at $5 per million input tokens and a massive $25 per million output tokens. That dwarfs the baseline cost of models like Sonnet. Those numbers instantly disqualify this model for independent developers or any application running thousands of automated queries on tight margins. The second barrier is the infrastructure itself. Anthropic currently imposes aggressive rate limits on the API. This creates a deeply frustrating irony. The Opus model was specifically engineered to run complex, multi-step autonomous tasks, but the API rate limits frequently interrupt and kill those exact same sessions before they finish. Unmatched cognitive capability doesn't matter if the API costs drain your entire department's budget, or if hard system limits bottleneck your autonomous agents halfway through a job. Let's map out the Claude deployment path. First, does your workflow require complex automation? If no, use Sonnet 4.6. If yes, check your margins. High volume, tight budgets stick to Sonnet. But for absolute precision with premium budgets, deploy Opus 4.7. This places Opus 4.7 firmly in the hands of enterprise compliance teams, heavy-duty system architects, and deep research scientists. General productivity users and solo app developers need to ignore the marketing hype entirely. Sticking with Sonnet 4.6 is the only way to protect your financial runway. Opus 4.7 is a highly specialized, heavy-lifting engine. It dominates its specific lane of long context automation, as long as you have the budget to pay the toll. Drop your specific use case in the comments below, and let's see if the ROI actually makes sense for your project.